Okay, so on to question 2. So question 2 is about this cute little fish. And the question says that fish propel themselves forward by pushing swirls or vortices of water backward with their tails. And the image to the right is taken from a computer model of the fluid dynamics of a fish swimming. So that's this. Over here you have a fish on the left, and you have these little blue dots, and those are the vortices that are moving backwards. So what the question is actually asking is, if we have a 15-gram fish and it's initially at rest, it will produce 2 vortices at first, and they're each going to be moving at 10 centimeters per second at angles 15 from the horizontal. So if we look more carefully at this picture here, and we draw a line for the horizontal, and then we also have some vortices, one moving off like this, one moving off like that. Each of these is an angle of 15 degrees, right? So this is also 15 degrees. Okay, and the fish is being propelled forward at a speed of 5 centimeters per second. So this is going to be 5 centimeters per second. And then also, we should probably note that these vectors here, the vectors of the vortices, these are 10 centimeters per second. Okay, so the question asks, what is the mass of water in each vortex? All right, so this smells like a conservation of momentum problem. Also, that's what this module is about. So let's just start by saying delta P is equal to 0. And here our system that's isolated is the fish plus the water. So system is equal to fish plus those vortices of water. And so another way of writing this is we can write P initial is equal to P final for that system of fish plus the vortices. And you can also always write this equation in terms of its components. So you could also write instead P initial x is equal to P final x, and also P initial y is equal to P final y. Now, initially it says that this is at rest, right? The fish is at rest. Also, the water is just sitting there at rest. So that means any initial momenta is 0. So these are 0. And so let's just work on one of these at a time. So we'll start with the x. So over here we have 0 is equal to the momentum final in the x direction. And we can further break this apart into the vortices and the fish momenta. So we could say the momentum final in the x direction of the fish plus the momentum final in the x direction of vortex 1 plus the momentum final in the x direction of vortex 2. And then now, of course, we know our handy-dandy that momentum in the x direction is equal to the mass times the velocity in the x direction. So let's write that out. So we have mass of the fish times the velocity of the fish in the x direction final plus the mass of vortex 1 times the velocity final in the x direction of vortex 1. And then we also have a vortex 2. So plus mass of vortex 2, velocity final x direction of vortex 2. Now, we know the mass of the fish, right? The mass of the fish here is 15 grams. We know the velocity of the fish in the x direction is 5 centimeters per second. We don't know the mass of the vortices, so right, so this is question mark, this is question mark, but we do know the velocity in the x direction for each of these. So let's figure out exactly what that x component of those velocities are. So I'll draw a little picture of our fish moving this way, and then we have our vortices that are going off, right? They're sort of going off like that, where if our horizontal is here like this, then let's do a better horizontal. Horizontal like that, and we have 15 degrees, and then this one, also here's the horizontal for that, 15 degrees. And so our x component is going to be something like this, right? We have a y component that's like that. This one has an x component like this, and then it has a y component like that. And we know the speed of the vortices is 10 meters per second, right? So 10 meters per second is the speed. And then using a little bit of trigonometry, we know that we have our Vx, right? So basically this line here, for either of these, is just going to be equal to V, that speed, times cosine of 15 degrees. Right, or we could write this as 10 meters per second times cosine of 15 degrees. And so that's our Vx here. This is 10 meters per second times cosine of 15 degrees. Over here we have 10 meters per second times cosine of 15 degrees. And so we can simplify this whole thing. 15 grams times 5 centimeters per second plus, and so if you notice that these two terms are actually identical, so we can write 2 times 10 meters per second times cosine of 15 degrees, and that is multiplied by our mass of a vortex. We're assuming the mass of those two vortices are the same. All right, and then all of this is equal to 0. So now we can just solve for our mass of the vortex, and that is going to equal 3.88